Hello, today we're going to be reviewing the Krebs cycle, and I hope you're following this video up with the one we had produced on glycolysis, because as mentioned earlier, some of the biochemical pathways that you'll be learning, glycolysis, Krebs, oxidative phosphorylation, beta oxidation, none of those are stand-alone chemical pathways. They are all cogs in a larger ATP producing machine. And we had discussed glycolysis continuing into Krebs cycle. Krebs is going to seem to operate as a central hub to some of those biochemical pathways. A lot of these different pathways flow into Krebs and then continue on to the oxidative phosphorylation process. So we see glycolysis continue on. Glycolysis produces pyruvate, which then gets converted to acetyl COA, as we'll discuss, and that goes into our Krebs cycle. Beta oxidation, when we chip off those long-chain fatty acids into 3 carbon subunits. Those 3 carbon subunits are acetyl CoA that begins the Krebs cycle. Even amino acids, if we choose to use those as an energy source, various amino acids can jump into Krebs cycle at varying spots along the way into production of ATP. All of these processes, with the exception of glycolysis, are going to take place inside the mitochondria. And that's where we'll get the bulk of our ATP produced. Not necessarily from Krebs directly, but Krebs and its associated pathways. As a continuation of glycolysis, we see the pyruvate produced from glycolysis enter the mitochondria and get converted to acetyl CoA. That's going to be key. When we look at that conversion, this happens as we cross over that mitochondrial membrane. Pyruvate converted to acetyl CoA, and we get an energetic product, NADH, for each of those conversions. Acetyl CoA is going to be considered the starting point for our Krebs cycle. So this is where we get our acetyl CoA from. A continuation from glycolysis, pyruvate getting converted into acetyl CoA. From Krebs cycle, we get 3 types of energetic molecules. We get 1 molecule of ATP, we get 3 molecules of NADH, and 1 molecule of FADH2. Now this is per a single turn of the Krebs cycle. But however, if you recall from glycolysis, we took a 1 molecule of glucose, broke it in half, and formed 2 molecules of pyruvate. Each of those molecules of pyruvate entered the mitochondria to get converted to a molecule of acetyl CoA. So for all intents and purposes, for every glucose molecule we broke down, we get to go through Krebs cycle twice. So anything that we saw on the previous slide, those products, the NADH, the ATPs, and the FADH2s, that production should really be doubled. The NADH and the FADH2 molecules continue on to undergo a process called oxidative phosphorylation. You'll also see that process called the electron transport chain. And that's where they are going to wind up contributing to our total ATP count. If you've been counting up so far, we expect to get 36 molecules of ATP for every glucose we break down. From the last video on glycolysis, we could see that we got 2. From a couple slides ago, when we had Krebs cycle on the board, we got 1 per turn. So per glucose, that's another 2. 2 from glycolysis, total of 2 from Krebs. So far out of our 36, we have 4. The NADH and the FADH2 that go through oxidative phosphorylation is going to ultimately give us the bulk of our ATP. I encourage you to go back and watch the video on glycolysis if you have not already, and look at the Krebs cycle that we had just mentioned as a continuation. Follow this video up with the video on oxidative phosphorylation to complete that entire process. And by that point, you will see where we get our total of 36 ATPs. Thank you. I hope you enjoyed.